Find the average value of the square root function, f of x square root of x, on the interval. We'll look at the formula and let's just follow the formula. So f average, that's not actually international notation, if be honest, and I saw different notations on this, is going to be 1 over 25 minus 0. Always find the exact length of the interval. It's not always the same as the b value, you will see later. From 0 to 25 of the square root of x dx. Well, the number in front of the integral is 1 over 25. And now let's integrate square root of x. If you're not sure how to do that, rewrite it as x to the 1/2. Integral of x to the 1/2 is 1/2 plus 1. That's 1/2 plus 2 over 2. That's 3/2 over 3/2. If you're already good in integration, then you know that when you divide by this fraction, you actually multiply by the reciprocal right away. That will save you some time. So we're dividing by 3/2. That's the formula of how to integrate x to the n dx. Add 1 to the exponent and divide by the number you got, plus c. For the definite integral, instead of plus c, I will have a bar from 0 to 25 equals 2 over 75. That's 25 times 3. And then I will have top minus the bottom, 25 to raise to the 3/2. That actually means I will square it and then find cube root of that number, minus 0. And the final answer will be 250 over 75, which is 10 over 3. That's the average value. That's the average value. The exact value was the same answer, but without multiplying by 1 over 25, right? So average value only has this piece in front of it. That's the whole difference. Every time we ask you to find average value, that means you should not forget to multiply your integral by 1 over b minus a. So that means that exact, just note, I will make note in blue. Exact value is just integral from 0 to 25 square root of x dx. And that will be 10 over 3, but without dividing by 25. So I will multiply by 25. That's 250 over 3. So that means that the area was changing, and this is my total area below the graph of square root of x, 250 over 3. But the average is 10 over 3. Very interesting idea over here. From 0 to 25. Second example has pretty cool application. A car was driving down a road in such a way that its velocity in meter per second at time t in seconds is given as a function v of t, 2t to the 1/2 plus 3. Find the car's average velocity to 3 decimal places between t equals 2 and t equals 4. Now you know what's the difference. We just want to find here average velocity. I will call it v average, of t. And I know that's just normal integral from 2 to 4 of the function we're given, vt to the 1/2 plus 3 dt. But we're also dividing by b minus a. That's 4 minus 2. Let's start. So I wonder, I was driving fast and slow. What was my average speed? That's the idea. 1/2 in front of the integral, and now I'm starting integrating. 2t raised to the, we already know this, 3/2 times 2/3. 2/3, we had this before, plus 3t bar from 2 to 4. I will have 1/2 in front, and I will have 4/3. Then I'm plugging the upper value, which is 4, raised to the 3/2 plus 3 times 4 parentheses minus, be very careful. If you want to factor out this 1/2, then put huge brackets outside and make sure that you have separately plugged top and separately plugged the bottom of the limits of integrations. Then don't mess up with parentheses because of this negative sign in the formula and because of the constant in front of everything. When I'm plugging 2, I will have 4/3, but now 2 raised to the 3/2 plus 3 times 2. What is 3/2? 3/2 is cubed and then a square root. So 4 to the 3/2 is actually 4 square roots and then cubed based on the properties of exponents. Square root of 4 is 2. 2 times 2 times 2, that's 8. So actually the first piece over here is 8. And so on and so on. Keep calculating and you'll get the nice answer, which is, what I got was 1/2 32 over 3 plus 12 minus 4/3 square root of 8 minus 6, and that's approximately 6.448. That's what it is. Average velocity was in meters per second. Meters per second. So that was my average speed.